For this video, I will be talking about ray tracing and cameras in Unreal Engine. The first part, I cover tips about ray tracing, how it works in Engine, and how to get it implemented, all the values you need to look into, stuff you might need to change. All of that is covered in the first part. In the second part, I talk about cameras. So here I explain how to get a cinecamera actor into scene, how you're going to change the focal distance, focal length, aperture based on what you want, how by changing these values you can enhance your lighting and showcase your scene in a more photographic way. And as someone who wants to go into lighting, your main aim is to understand cameras before you can do anything else, because cameras really help you establish your scene. So, yeah. What is ray tracing? It is a real-time rendering technique that is used to generate an image by tracing the path of light as pixels in an image plane and stimulating the effects of its encounters with virtual objects. Ray tracing produces a high level of photorealism and is most often used in movies and even in games, but an RTX is required. Otherwise, it takes a really long time to render. So before we get into ray tracing, we should know the basics of light. In nature, a light source emits a ray of light which travels and eventually to a surface that interrupts its progress. Four things can happen to this ray of light: absorption, reflection, refraction, and fluorescence. Absorption. Absorption happens when an incident ray of light is absorbed and converted into energy. It depends on the electromagnetic frequency of light and the object's nature of atoms. One must know that everything is capable of absorbing light. For example, let's look at photosynthesis. When sunlight falls onto a plant, part of that sunlight is absorbed and converted into energy. The color of the plant depends on the wavelength that is not absorbed by the plant. Here it's green. Reflection. Reflection is when an incident ray of light bounces off a surface. Here we have the incident light and it's being reflected based off the normal of the surface. Refraction, the bending of light when it passes one transparent medium to another. Here we have an incident ray passing from medium 1 to medium 2. Based on the refractive index of medium 2, this incident ray will bend to a certain angle to give out a refracted ray. Fluorescence. It is a type of luminescence that occurs in gas, liquid, or solid chemical systems. The energy is supplied by electromagnetic radiation, usually in ultraviolet light. It is an optical phenomenon in which molecules absorb high-energy photons and re-emit it at low-energy photons. The absorbed photons are usually ultraviolet, whereas the emitted light is in visible range. What happens to the reflected light? A ray of light goes through two things when it is reflected: either specular reflection or diffuse reflection. Specular reflection is when light is reflected at the surface. It follows the law of refraction. On a perfectly planar surface, angle of incidence is equal to the angle of reflection. And here, light intensity remains constant. You can also imagine specular reflection is when you hold an object in the light, and when you move your eyes, you can see a bright spot that follows your eyes. That is known as specular reflection. So in the engine, to increase the diffuse reflection is light that has been scattered when reflecting off a surface. Unlike specular reflection that is calculated based on the surface angle, diffuse reflection is calculated based on the structure of the surface itself. In the engine, the diffuse value can be increased to indicate more bounces of the light ray to enhance photorealism. So in Unreal Engine, by increasing the diffuse light value, you can in turn increase the number of bounces. This can brighten up your scene depending on how many bounces of light you have. Okay, so now let's get started with creating a project that has ray tracing. First, I'm going to create a blank project for this demonstration, and I'm just going to name it as Ray Tracing 101. Over here, if I give ray tracing enabled, all of the built-in stuff will be done for you. But I'm going to show it on how to add it to a project that doesn't have ray tracing enabled yet. So let's just create this project. And now we wait while it gets created. And so this project does not have any ray tracing implemented yet. Once Unreal Engine has loaded in, we're going to go to Edit, go to Project Settings, and in Project Settings, we're just going to click on All Settings, search for Ray Tracing, and you're going to click on this. Another thing you want to make sure is, we're going to type DirectX. So you have to make sure that DirectX 12 is checked. And if both of these things are done, we're going to click Restart Now and restart our Unreal Engine. So now the project is going to restart with ray tracing enabled. Unreal Engine has loaded and it's now using ray tracing. So now let's create a new level and start from scratch. 101. So don't save any of this. So now we're starting up a new level. First, what we're going to throw in here is we're going to put in a sky sphere. After that, we're going to take a directional light, put that in, and we're going to take a skylight, put that in. So a directional light is basically our engine's way of talking about the sun. So if we go to BP Sky Sphere and we hook up this directional light, it kind of acts as our sun. So the angle of which our directional sky is going to be rotated gives us the angle of the sun. So if we want to look at it, now we're going to rotate this and we're going to go back to BP Sky Sphere, click on refresh. So now the angle of the sun has changed because we've changed our directional light. And in our BP Sky Sphere, we can remove this colors determined by sun position and stuff. But for now, let's just keep it. So right now, we've changed our angle. But since we're in ray tracing, we're going to keep the directional light as movable. And we're going to keep our skylight as movable. Now we're going to look at skylight. Skylight basically takes whatever image is on your sky sphere and bounces the light based on that image. So if we had, instead of our BP sky sphere, if we had an HDRI, the skylight would help to create lighting based on that HDRI image. In the skylight, we can change lots of settings. If we didn't want the sky to be colored the way it is, we can go into BP Sky Sphere, remove this value, and go in here and change all these values to get whatever value, whatever color of light we wanted. So as you can see, I'm just changing these colors over here, and I'm getting a totally different lighting going on. Change it to whatever color I want. I'm gonna keep it like that. And here you can increase your cloud opacity. Let's just keep it at normal. Let's keep everything back to how it was for now. Say color is determined by sun position. Okay, now we have that. Let's throw in some geometry into our scene. Let's put in a plane. Let's stretch that plane out. So, in real-time lighting, you don't need to worry about your light maps because we're not baking any of the lights. So the need for light maps doesn't matter anymore. But if you want to do a mixture of both baked and real-time lighting, yes, you would have to consider light maps. But for now, we don't need to worry about light maps. So let's stretch all of this out. Let's, add a material onto it. Why not? Let's go to starter contents, materials. Let's go with, marble. Yeah, let's throw marble on there. Let's see how it looks. So right now, you can see there's kind of some reflection and stuff happening, but wait, we need to add a post-process volume. And we're going to go to unbounded, infinity bounds. So once we open post-process volume, we're going to go into rendering features. In rendering features, we're going to be dealing with the ambient occlusion. So here, under ambient occlusion, the intensity is how much ambient occlusion affects non-direct lighting for ray trace ambient occlusion. Lower values decrease the effect, while higher values increase how strong it is. Then we have the radius, controls the distance in unreal units that ambient occlusion affects. So we're not dealing with any advanced stuff right now. Now, ray tracing ambient occlusion, we want it enabled. We're going to give samples per pixels. Here, I've just given 20. Intensity and radius have been added in Unreal 4.26. In Unreal 4.25, you would just consider this, but you can consider this now. Global illumination. This, we're just gonna, if we want to have global illumination, we can select this, such as stationary lights, etc. So I've just selected this. Now, ray tracing global illumination. If we want to have ray tracing global illumination, we're gonna give type and we're gonna say the final gather. We can use brute force, but it's much more heavier on the system. So we have max bounces 6810, samples per pixel 16. These are values that I've set. Now we do not need to worry about both of these. We're going to go into reflections. For reflections, you have type. You can either select screen space or ray tracing. Screen space is kind of like raster, which is the old method. But over here, we're going to go with ray tracing. Now we have ray tracing reflections. Max roughness. This sets the maximum roughness value that ray traced reflections will be visible before falling back to raster methods that are less expensive. And maxed bounces sets the maximum number of bounces that ray traced reflection uses. More bounces create interreflection but comes at higher cost. So these two values, kind of just set them to 5 and 5. For shadows, we have hard shadows and area shadows. Area shadows are soft shadowings like ray trace shadows. In ray tracing translucency, we have maximum roughness, which is the maximum roughness value that ray trace translucency will be visible before falling back to raster methods that are less expensive. Then we have max refraction rays, which is the maximum number of refraction rays that ray trace translucency uses. Next, we have samples per pixel. Samples per pixel is the number of samples to use per pixel for ray trace translucency. We have shadows, and the shadows you can choose between hard shadows or area shadows. Area shadows, the same thing over here. It's just soft shadows like ray trace shadows. Then refraction, it's just to say that we can have ray traced refractions in scene. Now, under path tracing, we have maximum bounces. It's 32 samples per pixel. This 1600, Path tracing just has maximum bounces and samples per pixel. These are the default values that the engine gives us. For this video, I created a simple scene in Unreal just to showcase how ray tracing works. All of these are materials from Megascan, and some are the props that you get from starter content. So first, let's look at a translucent object. If we go into global post-process volume and type render, the settings that I've kept are intensity at almost 1. It could be 1, and we can set it to 500. I've given, for ray tracing ambient occlusion, I've given 20 samples per pixel. For global illumination, I've just selected it and said, oh, let's go back to 2. Intensity, it's just 2. And for ray tracing global illumination, we want final gather, max bounce is 10, and samples per pixel 16. Okay, yep. We don't worry about that. Then reflections, we want ray tracing reflections. Then I've kept it as ray tracing reflections, max roughness as 0.6, max bounce is at 5 and 5, sample per pixel is 5. Shadows, we've given hard shadows. And translucency is the thing that I wanted to show you guys. So for type, we've given ray tracing. So this is how translucent objects look with ray tracing. And you need to make sure when you go into the material object, you need to have 2 things selected for this to work. So over here, you have to go and make sure, let's click over here first. It's sided. You have to make sure 2-sided is selected. And for lighting mode, you need to make sure you've selected surface translucency volume. Otherwise, you won't get the ray tracing effect. So let's minimize that. And as you can see, it kind of looks, it's not completely translucent, because if we try to do fake translucency with raster method, this is how our translucent object would look. But this is the old method of generating. This is not ray traced. But in ray tracing, this is how you do get a lot of reflections going on, as you can see. And you can see if you reduce the number of refraction rays, it'll slowly turn darker, because the refraction ray is the number of times the light is bouncing inside. So we're going to keep that at 10. You can switch this to area shadows or hard shadows depending on if you want soft shadows. I've just kept it at hard. Then this is standard. I have not changed it. So yeah, if you want to have glass and stuff, you'll have to change those couple of settings to get it to work if you want ray tracing. Or you can just go with the raster method, which saves you a lot of performance. But for this demonstration, I'll keep it as ray tracing. And to make sure that I have some of my reflections correct, I did have a reflection sphere capture. And also you can see that when you look at any image, you can see there's a lot of small noise happening, and that's due to the ray trace pixels that are hitting every surface, trying to create this light. So if you move really quick, you can see how it kind of takes time to adjust the lighting. We can also see this if we go to path tracing, and you can see how the light populates the scene. This is because every pixel is trying to calculate the lighting, and this is how we can visualize how exactly it works. Another thing to note is how the skylight works. So in this scene, I have added a skylight and a directional light and a sky sphere. So my light source is connected to my sky sphere over here. And my skylight, I've kept it at 0.5. But if I keep increasing the if I decrease the intensity, it decreases. Go up. Now if I make it to 1, it gets brighter. So instantaneously, in real time, the amount of light that bounces throughout my scene will increase when I increase the intensity scale. Let's go with 2. You can see how it gets brighter and brighter. But I'm gonna go with 1 for this scene. Now let's go to light source. My light source, the intensity is just 2. And one thing you need to keep in mind is over here, you can select ray trace shadows. It increases your performance rate. So if it was a game, you would want to make sure you don't select this for every single light in the game. But yeah, affecting ray trace reflections, all of these kind of impact your performance. So in a game, you should be very, very selective on which lights have these. Over here, you can increase the number of samples per pixel of this light. Skylight, I've selected all of them and I've given samples per pixel 6. The more number of samples, the more photorealistic that your ray tracing looks. Another thing to know is that when you're in light source and you want to, say, soften how the light is hitting the ground, you would just change the source angle. And as you can see, the light kind of bleeds instead of having sharp edges like this. So you're able to do that with ray tracing. So for the second part of this video, I'm going to be talking about cameras in the Unreal Engine. So I'm going to explain how to set up a camera and how to make sure your camera has the correct focal length, focal distance, and aperture that you want, and how to enhance your photos and enhance the lighting using a camera. All these tips and tricks will be very helpful and are easy to understand. Once you start using them, it's really easy, and it might need a couple of tries to fully get used to it, but once you're used to it, it's standard and there's nothing really tough about it. Exposure and ISO. ISO is a sensor's sensitivity to light. By going up from ISO 100 to 200 to 400, etc., the sensitivity increases. That means if we're in a dark environment, we would want a higher ISO. But higher ISO can also mean that there is more noise in the film. So it would be more grainy if we took a photograph with a higher ISO. Exposure is nothing but the amount of light that a sensor receives during each shot. In Unreal Engine, the default ISO is set at 100. Aperture. So aperture can be defined as the opening in a lens which through light passes to enter the camera. It is expressed in f numbers like f 1.4, f by 2, f by 2.8, and so on to express the size of the lens opening, which can be controlled through the lens or the camera. In Unreal Engine, we have a variable that has the different aperture numbers, and we can control it by entering any number we want. It will be shown further in this video. Focal length is usually represented in millimeters and is the basic description of a photographic lens. It helps us reduce the field of view. So if we have a higher focal length, we have a lower field of view. And if we have a lower focal length, we have a higher field of view. And I will show this further in the video. HDR stands for High Dynamic Range. So HDR imaging is a technique used in photographic imaging. HDR, as its name implies, is a method that aims to add more dynamic range to photographs, where dynamic range is the ratio of light to dark in photograph. Instead of just taking one photo, HDR actually uses 3 photos taken at different exposures. It uses 32 bits per channel. HDR tries to replicate the eye as much as possible instead of trying to be like a camera. So whatever image you get has to be the image that you see from your eye. And HDR imaging tries to cover the whole spectrum of covers by using multiple exposure values. And so there's a clear contrast between the shadows and the bright areas. Whereas if you look at low dynamic range, you can't distinguish between the shadows and bright areas, and it only uses one exposure value. The problem with HDR is you need HDR TVs or monitors are needed, but monitors exist, but the only thing that doesn't is HDRI TVs. The TVs only go up to 10 bits to 24 bits of color depth, but you need a 32-bit color depth, which TVs aren't designed yet to handle that. So whatever you see on TV, even if it says HDRI image, it's HDR image, sorry, it's you technically can't see it with your TV. You have to have a specific monitor that allows you to visualize HDR images. So to talk about exposure and ISO, we first need to understand what exposure is. So exposure is kind of like when you're outside, the sun seems super bright, but as soon as you come inside, it takes your eyes some time to adjust because it's super dark. And that's nothing but the light entering your eyes has reduced when you come inside. So your eye, basically, the pupils in your eye have to expand to enter more light. That's the same thing that happens with the camera. And so when you're outside, the brightness has to adjust. It has to be it has to maintain the darkness and the brightness, but when you're inside it's too dark, so you have to maintain that. And one way we can find out in engine to figure out how HI is adapting to exposure is through HDRI adaptation. So now we can tell how much exposure is there, how much light is going through at each part of the game. Lux is a measure of light. It's a lighting unit, and as you can see, minus 2.65 eV is the exposure at that current place, and over here it's minus 1. And if we go a bit higher, it goes to minus 1, and right there it's going to 2 to 3 almost. So based on that, we want to figure out what is the exposure of this entire place. We can actually change our exposure by clicking on these two values, and we know the least exposure it has is -8, so we're going to say -8 exposure on that. Now we know that as we go higher, it kind of goes all the way to around 4 or 5, so we want to switch that to 4. And this allows, we don't have any loss of exposure values. Another thing you can do is you can set a fixed exposure value by going over here and changing it, setting it to a fixed value. So no matter where you move, it's just going to be constant. You won't have a moving exposure. But if you're in a game, you kind of want to go with this change in exposure, because if you're inside, you want it to get brighter. You don't want it to be dark all the time. So that's a very good thing to note down when you're working with lighting. You want to make sure your exposure is correct, because you don't want the color to be blown out. You want lighting to be blown out all the time. And this is a very, very important thing when you're working with lighting, is your exposure. Over here, your histogram, low value kind of tells how much you want your histogram to be. We're gonna set that back to default. And then this is your histogram log max. So we can increase this, and this just goes up to 16, which is the highest in Unreal. This goes up to -16. Set it back. And also the min and max brightness are always going to be -10 and 20. That is the standard for exposure. It's always going to be between -10 and 20. This is the Unreal Engine standard values that you get, but I had kept mine at -8 and 5. Now let's go with 4. Yeah, so this is what I had kept, because I have graph values that go till -8, and when I zoom around, I can get areas that have almost -4. So you can imagine you can change your values based on your scene. So another thing that I would like to talk about in this video is setting up a camera and making sure that you have all the correct values for your camera so you can get the perfect picture. So I'd say let's take this angle and throw in a create camera here, and we're going to say Cine Camera Actor. So now we have this, and we have this Cine Camera Actor. We have two. We're going to delete this one. We don't need this. Gonna go to edit and we say delete. Yep. We have this Cine Camera Actor. Now let's go to perspective and let's go into Cine Camera Actor. So I feel like choose an angle for our picture. I feel like this angle kind of feels good. Let's go a bit closer. Yeah, this angle. Let's just, for this demonstration, let's just go with this angle. Like this. We can choose the different types of films we want. So if we go with Super 8, go super close. 16, 35. So I'm just gonna go with the normal 16:9 digital film one. I don't want to go too in depth with that. So I decided to position my camera in this scene. Where in this scene, I wanted to focus on the statue and kind of blur out all the stuff in the side. So for that, what I did is I made the focus plane right at where the statue is positioned. And that I changed my, when you change your focal distance like this, it changes the plane. So I kept it right at where I wanted the statue to be, like right there. Yep. And then what I did is I changed my current focal length to 35. So your current focal length, basically, it determines your field of view. A higher focal length will give you a less field of view, whereas a medium focal length, like around 50, gives you a medium focal field of view. So lower the field of view, higher the focal length. Lower the focal length, higher the field of view. And that's very important to keep in mind. So I kept it at 35, and I kept my current aperture as 1.2 because I really wanted the blurring to happen with this chair over here. And if I increase it, you can see how the chair becomes clear. An aperture is nothing but the amount of light that enters into your camera, because lower the aperture, wider the hole of the camera lens, so more light will enter in. Higher the aperture, smaller the lens, and more light, like it takes less light will enter in. So if I keep it really low, it tends to blur out the stuff in the side based on where my focal distance is. So this is what you want to keep in mind when you're working with camera, so you can get a better image of your lighting, and you can blur and work with the focal length. So it's very important to keep all of this in mind. Other stuff about the camera is an important thing you can do is you can also go into transform, and you can lock the actor. So when you're working with cameras and you accidentally move your mouse and the whole camera changes, that won't happen anymore because you've locked your actor movement. And that's very helpful when you're working with it. Once you have the picture that you want to form and you know this is going to be your image, you can just lock it and it's done. Always come out like this. And those are some useful tips about cameras that really help a lot to create that final image. So this is another scene that I had created using Megascan assets. And here you can clearly see how the aperture, the focal length, and the manual focal distance matters a lot when you're taking a scene. So over here, my manual focal distance is 666. That means it's right over here, 66.6, sorry. And it's right at this pillar because I wanted the pillar to, have a lot of detail. And if I change this, you can see how from the pillar it shifts into, this statue becoming clearer. And if I shift back, sorry, my pillar becomes clearer. And using that, method, I created a cinematic video. So for creating cinematics, you would go here, add a level sequence, and in your level sequence, pretty sure it's one of this. Yep. So in your level sequence, you would track, add sequence, and you would add your camera actor. And over here, you would click this at the correct position. You'd click it at the correct position. And so my position over here was my focal length was 66 points. My focal distance was 66.6. But as I panned across till here, I changed my focal distance. And now my focal distance is at 400. So if I show you guys that in a video, you can see how it switched. So look at that. So it was starting at 66 and now it went all the way to 400. And you can see that this really helps showcase your lighting and stuff by dealing with cameras, because camera and photography is the main thing you need to know for lighting. And you can see over here, if I reduce my aperture, it becomes super blurred out. But I didn't want that. I wanted it to be 11, just normal. Yeah. So by understanding cameras and understanding ray tracing, you can put together a really, really photorealistic image that looks almost real. Like you can't even tell if it was done in an engine. And I think, that's what lighting is all about, to create something so real and to make sure your lighting affects all the art inside your scene to make it look real. So yeah, that's all I have for this video.